Hey everyone, welcome to TestFlix 2023. I'm Akshay this side, and in this session, I'm going to talk about blending automated testing processes with deployment in GitLab. So to start with, let's understand a bit about GitLab. So this is from the About GitLab section of the GitLab official website, which states that it is essentially a DevOps platform. So other examples of such a platform include Jenkins, GoCD, TeamCD, etc., to name a few. In Gojek, we use GitLab mostly for our testing and deployment processes in our CI/CD processes. So before we get into the details of the topic, let's try to understand a bit about the problem statement. So what happens is in a conventional QA automation process, usually the tests reside in a project which is different than the application repository or the service repository which is under test. What this means is that when the QAs or the SDETs, when they design pipelines, usually they end up doing that in a standalone fashion, meaning that there is a separate or a standalone pipeline that runs the tests in an asynchronous manner, usually in the nightly or scheduled builds. Now, this comes with a few problems. For example, it makes it difficult to pinpoint the test failures and then attribute them to the specific changes that are going into the application, right? Because what happens is, consider this example where uh, the application development is happening for a day. There are 5 or 6 or 7 changes going into it, and then the tests run in that nightly or the scheduled build, and then the next day you see some failures, but then you don't know which of the 5, 6, or 7 changes have caused the failure. So as such, it becomes difficult to pinpoint the test failure. Moreover, it might not be optimal usage of the CI resources because you are running the job separately and not with the application side changes, right? So in this slide, I've tried to put screenshots of how the pipelines usually look like. So the pipeline one is the application side pipeline, which typically has like a few linting checks, unit tests, etc. And then it gets built and gets deployed to integration, right? And let's say then there is a separate functional testing pipeline which runs in a standalone schedule separately, right? So yeah, so that's about the problem. But then how do we address this problem? So one of the ways to go about this problem is using a multi-project CI setup, right? So such a strategy will allow us to combine two different pipelines into a single multi-project pipeline, right? So in this slide, in this animation, you can see that there are two different pipelines that have been combined to look like a single pipeline, right? So the application pipeline, which becomes like an upstream pipeline, and the test pipeline becomes like a downstream pipeline, right? So you can see that the, the tests are now running along with the application side changes. There is no standalone pipeline which is running separately, right? So this is sort of a crux of the solution, right? But then how do we implement this in GitLab? But then even before we go into the implementation details, I would like to stress on the fact that GitLab is just an example to show how it can be achieved. This can, of course, be achieved in most of the modern CI tooling systems like Jenkins, GoCD, and TeamCity that I named earlier, right? What's important here is the strategy that we are using, right? So in this slide, I'm going to talk about the implementation part using the trigger keyword. So the trigger keyword in GitLab is essentially the crux of this whole session, which sort of explains how to combine two different pipelines. So as you can see here, there are two different code snippets, which are nothing but two different pipeline configurations following the GitLab YAML syntax. On the left side, it's an application project, which forms an upstream pipeline for us. And on the right side, you can see that it's a test project that forms the downstream pipeline config for us. In the application project pipeline, you can see that there are a few stages defined. We'll be focusing on the testing stage because we want to talk about combining the testing part in the application side pipeline. So as you can see, it is attached to the stage functional test, which is declared here. And then there are a bunch of variables, which I'm going to talk about in the later part of the slide. Uh, there are also a few other parameters. And here is the main part, which is the trigger keyword declaration that forms like a bridge between these two pipelines, right? On the right side, we can see that uh, all the details of the testing job are declared here. It's all declarative syntax in YAML, so fairly easy to understand. So you can see that run my awesome test is basically a downstream job which defines what should be done as a part of this testing job in this pipeline. So you can see that other than the script part, which is basically which will have the key steps to execute the test. In your case, it could be anything. It could be a maven command or it could be a gradle command to invoke the test. But the important part here is the rules, which say there are a bunch of rules here which are containing a few variable checks. So you can see that we want to ensure that this gets triggered only when the CI pipeline source has a value pipeline, and the upstream project ID has a certain value. So you can see that application project one code, right, which is declared here 39941. So that is combined here and we are comparing that with the value of upstream project ID, which is coming from here. So this is where the variables which we talked about earlier are coming into picture. You can see that I'm populating the default values of some of the predefined variables defined on the right side to some of the new variables that I need to pass in the downstream, right? Now, why we are doing this copy is because the predefined values or the variables which are coming here will have different values for this project and this project, right? So what we are doing is we are essentially copying the values of application side project into different variables, which can be seen here. And then in the test pipeline configuration, we are using that for our rules. And then you can have multiple jobs for running different suites. So you can have different set of rules to satisfy that so that this job gets attached in the downstream pipeline using these conditions, right? So let's get back to the important part of this session, which is the trigger keyword, right? So in this trigger keyword declaration, I am specifying that the project should be GitLab CI test project, which is basically this project. And then I want to target the main branch of that project because then it's also possible to override this value and sort of have any custom branch to target on the test project, right? So that's pretty much about it for the implementation part using the trigger keyword. Simple and easy to understand, right? So now let's try to understand how this makes an impact for us and how this addresses the problems that I talked about in the initial part of the slides, right? So such a multi-pipeline CI testing setup will allow us to use the trigger keyword and it will combine the testing pipeline with the development pipeline itself, right? This means that now there is no need to have a different standalone schedule or a different pipeline where you might need to do automated or manual triggers separately, right? So such a setup will make it easy to understand the failures on a per change basis, thereby leading us to uh, segregate and track, debug, and fix the test failures for each change that is going into the application or the service under test, right? It is also possible to pass the parameters like I mentioned in the previous slides, right? We were passing a few predefined CI variables from upstream to downstream, right? So these could be actually useful in sending readable and easy to understand Slack alerts or email alerts with the specifics of each job. In this slide, I've tried to put a screenshot of how the alerts look like for us, right? So here you can see that at the top, it states the result for what is the test job name and the job ID, which is coming from the GitLab variables, right? Test group is something that we passed again from upstream. Uh, it's called my test tag here. And then there are a bunch of other things like who was the pipeline triggered by, right? And on which branch of the application project, right? We are also logging extra details like what is the branch on the downstream pipeline and what is the name of the downstream pipeline project, right? And a few other testing statistics which are seen here. As you can see, it is very intuitive and it makes it very easy to debug the test failures on a per change basis. As there are also extra links for going to the GitLab job or the pipeline itself and the report portal logs as well, right? So this is a bit of a Slack integration that we have tried to put into our test framework, which makes the whole thing possible end to end, right? So that's pretty much it about the topic itself. I hope this was useful. But again, I would like to stress on the fact that GitLab is just an example here. This should be possible pretty much with any modern CI/CD tool which is available in the market, right? So to conclude, I'm also putting a link to the blog where this topic is discussed more in details with some more examples. I hope this session was useful to you, and I also hope that you get to implement something similar in your project for your teams. And if you encounter any problems, I'm happy to discuss this more. Feel free to reach out to me on LinkedIn and have a fun time at TestFlix 2023.